year. Therefore, what can I do in the last few days to bring up my grade? Nothing. Okay? So I really do need you to focus. If this is your review, if most of these problems, there's not enough space on the paper to do the problem. So I would strongly urge you to get out a sheet of paper as well. Don't tell me you don't have paper. Okay? You figure it out. If you owe me any tests or quizzes, if they're not done by Friday this week, they stay at the grade they are, which is a 0. Okay? Some of you owe me things that are 3, 4, 5 weeks back as far as tests. Okay? It's not done by Friday this week. And don't say, well, you weren't in your office. You know what? I have another portion of my job. Don't make this last week, your priority that, oh, well, I haven't done anything, therefore now I want to. Don't play that game. Okay? All right, I am looking at the first section, numbers 1 through 15. These are a system of equations. They are linear. Okay, meaning you get an x and you get a y value. If you had graphed these, it would cross. If they don't cross, there's no solution. If they lie on top of each other because they're the exact same line, then there's infinite solutions. So there's different ways to solve these. Which is the best way to solve it? I don't know. But we have to go back and take a look. So anything from 1 through 15 you want to take a look at.
Let me go over number 10.
Number 10, I'm there with you. That's a great problem to start with. First item, I would say, you might want to think about trying to graph a problem. And then you look at it and say, well, the cover method doesn't really work real well to graph this. Remember that? I would cover up, I'd say 3x equals 7, so x equals 7/3. I don't know where 7/3 is on a graph. Okay, I could find about where it's at. So the graphing method's not going to work by using the cover method. The next way you might look at it, say, am I able to solve for one of the letters very easily on one of the problems? Let's see, I can't solve for x or y real easy for the top problem or the bottom problem. Okay, so then the last way would be, is what we need to do is we want to try and add the two together. We want to try and add these together to see what happens. Well, if I add them together, I get 9x minus 6x equals 21. That doesn't work. What do you got, Preston?
What's the difference between the ones that have the bracket symbol on the side and the ones that don't?
We got lazy.
Okay.
Yeah.
Can you multiply by the opposite number?
Yes. So what would you like to multiply? What would you like to get rid of? X or y? What are you seeing? You're exactly right. X, okay. So I have a 3x and I have a 6x. So should I multiply the top equation by a number or the bottom equation by a number, or both? Both? Is there a number I can multiply this top by that this get an opposite of on my bottom?
Let's see what you do. No, just the top.
Top. What should I multiply the top by to get rid of the x's if I add them together? What do you got, Gabe? Yeah, buddy. So if you multiply everything by -2, here, here, and here, that's going to give me -6x plus 4y equals -14. Does everybody see where those numbers just came from? And the reason why we're doing that to the top, if I add now, if I add these two together, so I'm bringing this one straight over, oh, cool. We wanted those to line up and cancel out. That gives me 0. Okay, let's see. Oh, you know what I mean? That's a minus sign right there. Isn't it?
Yeah.
Yep.
And then what happened here? And what happened here?
0 cents.
Is 0 equal to 0?
Yes.
That's true? If I had graphed these, it would be the exact same line. It lies right on top of itself. So how many solutions are you talking about? How many points of contact do the same line touch each other?
Infinite.
Infinite. That's how many solutions you have. Okay, there's infinite solutions. It's the exact same line. Andrew, that was an awesome one to start out with because that's definitely one of the things you're going to see. I bet you're going to see something that's going to have an infinite solution on the test. Yo. Who do you got? Where'd you go? I gave one yesterday. I just gave it to you yesterday. You don't have it? Well, why not? Do you often throw away review sheets that are given to you the day before? Why not? Yeah. 5? Perfect. Number 5. Angela, that's a great one, right? I like this one. Because it's kind of got a lot of junk with it. Alright, so we want to solve this, but there's a few things that are happening with this problem. I have some like terms, I have some things I need to manipulate around, so I need to clean up the problem before I start doing any elimination or substitution or anything like that. So I'm going to look at my very top. There's nothing to combine that with, do you agree? So I'm just going to rewrite that here. And then I have y all by itself, okay, we're good there. If I combine those together, I'm going to wind up with negative 29. Is that right? So let's move this negative 29 over. So I'm going to add 29 to both sides.
Isn't it 6y? Or did we get rid of the 6? Yeah, 6y.
Is 6y?
It's 6y.
Thank you. So that's a 6y right there. So that should be a 6y right there. Are we correct so far? All right. So I combined on the left side. I had negative 29. I'm going to add that to both sides. So that's going to give me. So does that first equation make sense? I just wanted to clean it up a little bit. I'm not done solving the problem. My next one. I'm going to take a look here. I have a 2x and I have a negative x. So that's just x, right? I have a minus 3y and it's equal to 7. Okay. I guess I could try and graph it. Nah, graphing wouldn't look good on the green because I'd get y equals negative 7/3. And that's not really nice to graph. Is there a number that I can multiply either the top equation by or the bottom equation by that when I were to add it to the other equation, something would fall out? So right now, if I were to add these two equations together, I'd get 7x, 3y equals 1. That's not going to help me. What should I multiply one of them by? What do you got, Angelo?
Negative 6.
Negative 6? Oh, to get rid of the x's, I like it. So if you multiply this whole bottom one by negative 6, so this top equation stays as is. Agree? Mm-hmm. Now that might not have been the choice you might have had. Some of you might have said, well, I'll just multiply by 2, but we'll go with our first here. Okay, that works. Now if I add the two equations together, what value is gone?
6.
The x is, that's gone, so I get 0 plus 24y equals negative 48. So what's y equal to?
2.
Negative 2. So y equals negative 2. Am I done with the problem at this point? No. What value do I need to find? I need to find x. So I'm going to take that y equals 2, and I can plug it in here, or here, or here, or here. I think this might be the better of the places to put it. So I get x minus 3. What am I going to plug in there? What was there? A y, and I'm going to plug negative 2 in. Okay, so x plus 6 equals 7. What's x equal to? X equals 1. So you could kind of probably leave it like that. I would say on the test it's going to be probably a multiple choice scenario. So the answer would be 1 comma negative 2. Meaning that's the point that the two lines would intersect each other if you graph them. That's where you're going to go with this problem. Is this starting to kind of come back, make a little more sense? I heard a question. Yeah, go ahead. Look at two different x values?
Yeah.
Okay. Number 2. Okay. So what'd you do?
I multiplied it by negative, or the bottom one by negative 4.
I like it. Multiply the bottom by -4.
Cancel it out, yeah.
Okay.
And then the 7.
So let's bring this down. So -4x plus 7y equals -2. 4x plus 4y equals -20. Do you agree with that?
Yeah.
Cool. So now when I add them together, the x's are gone. That gives me 11y equals -22. Do you agree with that?
Yeah, and then y equals 2.
Y equals -2.
Negative 2.
Okay. So if I take this value, it's a y value, I can plug it in here or here, your choice. I'll do the top, so I get -x minus y equals 5 was the original. So I get -x minus 2 equals 5. Do you see why it's -2?
Yeah.
So that is that one of your x values you got? Do you see where you made your error? So the answer should be written like this. And that's where they will intersect each other.
X is on the negative 2.
Sweet. Sometimes that double negatives kind of get goofy. Is there any more from the top first 15, or should we move to the next section? 16, 17 are both graphing problems. Yeah, what do you got?
I need help 16.
Do what?
16?
16? Sweet. I'll do both 16 and 17. Cool. We're going to graph these. We'll do the best we can on not having a grid. All right. I would say the very first one, cover method, is going to work nicely. So 3x equals -6. So what's x equal to? -2. Agree? What's y equal to? Y equals -6. Let's pretend I can draw a straight line. Does everyone agree with how that one just worked? Remember, the cover method works nicely when things break down all the way. All right, let's do this one. -x equals -3, so what's x equal to? Positive 3. What is y equal to? It's 3/2. 3/2 is what? 1.5. Are they going to intersect each other? Yeah, you might be able to do that a lot neater on your page. What did you find it to come out to? Mine's just not big enough. -4,4? How do you verify if this is correct? Plug it in. So that's an x and y value. So that's -12 plus 4. -12 plus 4 is -8. That's not it. That's off a little bit. You want to get a little closer? Go ahead. -4, 3. Let's plug that in. So I get -12 plus 3. That's -9, so that's off a little bit. You get another answer, Preston?
I got -5, 5.
-5, 5. Let's plug it in, see if it works. That's -15 plus 5. That's -10. That's not going to work. Gage?
-4, 6.
-4, 6. Let's Plug that in. I get negative 12 plus 6. That's negative 6. That works on the first one. Second one, negative negative is positive, so that's 4. It's 4 minus 12. No, it's going to be off. That worked on the first one, though.
Would it be negative?
What do you got?
I was saying, would it be negative 4, 5?
Negative 4, 5. Negative 4, 5. That's negative 12. Nope, that's not going to work. Won't work on the first one.
Negative 4, 3.
So it has to have a 6.
That's
for the
already
second
worked.
one.
Yeah, okay. Negative 5 what?
Negative 5, 6?
Negative 3.
No, it's not going to work on
What
first.
about negative 6, 6?
Negative 6, 6.
Negative 3, 3.
Negative 6, 6. So that's negative 18. Nope. It won't work on the first one. So it definitely does exist somewhere over here. The hard thing sometimes on graphing is not always the best way to solve it. Agree?
Yeah.
So if it's not the best way to solve it, how should you go about doing it?
Wait, is it negative 3?
I don't know. Negative 3, positive 3. Let's see. Let's do it this way. Let's multiply this by negative 2. So that's negative 6x minus 2y plus equals positive 12. That's equals negative x minus 2y. Whoa. There should be a positive. Doggone it. I'll tell you what. That's a negative. Should have been a negative. All right. Equals negative 3. So that's 5x. Oh, jeez. Are you kidding me? We give you a problem like that. X equals 9/5. Yeah, we're going to graph that. Sheesh. And then what would I technically have to do with that answer? I'd have to plug this x value in either here or here, and you'd solve for the y value. That was a bad problem. I'm sorry. I don't know what they might have to tell you. 17. Looks like they want us to graph it, yes? Bless you. Positive 2. And then that's going to go down 2 over 3. Correct? That's what this line looks like. Cool. And then this one is negative 5. So I'm going to go up 1, right 2. What did you guys get? You guys got the grid. Is it 5, negative 1? I don't know. Or is it 6, negative 1 or negative 2? I don't know. 6, negative 2. So if we plug this in, negative 2/3 of 6 is negative 12/3. Negative 12/3 is 4 plus negative 4 plus 2 is 2. That works. That works. And then that should be a negative 2, right? Okay. Yeah, that worked. And then half of 6 is 3. 3 minus 5, negative 2. That's totally the answer. Good deal. On a multiple choice test, you get stuck on this. What should you do? What do you think? Go ahead. Yeah, just plug in each answer, and you're looking for which one's true, right? What does he say? He's just babbling over here.
I thought you were talking about like test taking strategies.
No, I agree with what you're saying. But like, if you got to this problem, you're like, gosh, he has one answer being 2, 3, and one answer being 3, 3. Try and plug both in and see which one gets you true on both, right? And true means like 6 equals 6 or 10 equals 10. What you got, Ben?
So is there going to be a part of the test where we have to graph equation like quadratic or exponential?
I would say on Friday's version of the test, It's going to be the written portion, so it's not multiple choice. Okay? Yeah, Reese.
Can I please use the bathroom?
You, anytime. You never have to ask. Just go. What else do we see on that front page? Are we okay, or are we ready to move to another page? Doesn't mean we can't come back to that front page a different day. Moving on. All right.
Are we reviewing
Tomorrow is the district Algebra 1 that we'll do on the Chromebooks. Yes?
Is negative, I mean, is 20 infinite solutions?
Let's take a look. Oh, these are the inequalities, right? So this means we've got to shade a region. Remember that? All right, so let's take a look at number 20, like you asked. Y is less than negative x. Y is greater than x. So this has the shaded region that goes to it. So it's not, yes, you do have an intersection you would find, but then you'd have to realize there's a region to graph. So that's plus 0, so that means right here. So from that, I'm going to go down 1, right 1. And is it a solid or a dotted line? And what stands out to make it solid versus dotted? It's dotted because it's not equal. Good. I like it. That's this one. Where's the y-intercept on that one? 0, 0. So and I'm going to go up 1, right 1. Solid or dotted? Dotted. So I have a region here, I have a region here, I have a region here, and I have a region here. Only one of those regions is our shadable region. I can't use 0, 0 as my test point. Why not? Yeah, they go right through the center. Okay, so perhaps pick a point that would be out here. I don't know, maybe 10, 0. Why am I picking 10? 10 is always an easy number to plug in, right? So let's see if this gives us a true scenario. So that's an x value, that's a y value. So if I plug that in here, I get 0 is less than negative 10. True or false? False. Okay, now, should I just move to a different region or should I try the other one as well? Right, because if I get false, false, that means diagonally across would be the true, true automatically. Does that make sense if I said that? Okay, so I take that, plug it in. So I get 0 is greater than 10. That's also false. So that means this whole region is false, false. Diagonally across is right over here. Here's our region we shade. That's going to be where our answer falls. Cool? Yeah. 18. Uh-huh. I'd say we probably could do the cover method even though it's going to be fractional things. The reason I say that is because we're shading a region. Does that make sense if I said that? Okay. Let's get our xy axis. If I cover this, what's x equal to? 3/2, which is 1.5. Agree? If I cover here, what do I get? 3. Solid or dotted? Dotted. If I cover this, what do I get? Negative 3/2, which is negative 1.5. Yes? Agree? What do I get here? Positive 3. Solid or dotted? Solid. Is 0, 0 an okay test point? Yeah, the lines don't go over it. 0, 0 is a great test point. Why do we pick 0, 0? Because it's easy to plug 0 in. Okay? So I get 2 times 0 plus 0. 2 times 0 plus 0 is greater than 3. True or false? 0 greater than 3. False. Should I do the other one to see if the other one's a false, false? Yeah. Might as well. So plug 0, 0. 2 times 0 minus 0 is less than or equal to negative 3. 0 is less than or equal to negative 3.
No.
That's also false. Here's the nice thing. Is this region down here is false, false. So that means this region up here is my true, true region. What are some ways that we might try and catch you on this problem? We might alternate the solid versus dotted lines. So be aware of that. I bet you that kind of problem, we would have the exact same graph 4 different times if it's multiple choice. We would have one both being dotted. We'd have one both being solid. We'd have one being the opposite of solid versus dotted. So realize and recognize how that problem might take place. Okay? Yeah, the solid lines, when you have this, that dictates it's solid. If it doesn't have that, it's dotted. But that's how I could have this problem, modified on the test. Does that make sense, everybody?
Yes.
I might have the exact same graph, but you might have one of the graphs being this. You might have one of the graphs being this. And I might have one of the graphs being this. So they're all the same graph. It's just we're looking for the solid versus dotted. So just be aware of that. You got Benny?
We look at number 21.
2-1. 21. I'm not going to give one of those to you like on the test like that. And I'll tell you what, if it shows up on the test, we'll do it as a group and we all get the same point. Because I won't do the 3 regions. Okay? Cool? Deal? Sweet. Okay. Alright. Moving on. 22 through 27 looks like we're matching graphs up. So the ones that are shaded regions have the inequality sign. And we just got done with the exponential. So D and F are, D is a decay graph, F is a growth graph, so they're exponential. You know that parabolas are shooting hiccups. We're all good. Does everyone feel okay with 22 through 27? Calculators used on the whole test, so bring one. Don't just rely on mine, because you know that some of you are getting mine going, oh, it doesn't have this key. You're at the most affluent high school in Colorado. Pretty sure that scientific calculator exists someplace that you can get it. 28 through 36. Simplify. Does that mean simplify, you're using the calculator and it's getting a decimal answer? Perfect squares, good. So why don't we just run through? I'm just going to put these up real quick, and let's see if we can run through them real fast. That might be all I can squeeze up, but I'll get the last 3 in there. You have that, so you have I for an answer. What's the square root of 100? So I get 10I for an answer, done. Good? Where did the I come from? Negative under the square root, right? Next one, square root 112. Square root 112 doesn't break down real nicely. Okay, it's 10 point whatever on the calculator. So let's break 112 down. Okay, so let's go, 2 goes into it. So that goes in 56 times. 2 goes in 56, 28 times. What does that give you right there? Okay, so I'm going to put the first 4 underneath there. Still with me? 28 is going to break down to 2 and 14, or 4 times 7. Do you agree with that? So I have this. Let me pause there for a minute. Could I have broken 28 down to 2 and 14 and then 2 and 7?
Yes.
And then the 2 and the 2 is what gives me the 4?
Yes.
So square root of 4 is? 2. Square root of 4 is? Multiply the 2's outside, what do I get? 4. What do I still have left under the radical? Done. 4 root 7 is the equivalent of root 112. Root 48 over 49. What you got, Preston?
I was just gonna ask there's a little box by the 35. You know what that's for? Is
Or like a random box.
that for anything, or is that just an error in the computer?
That inside that little itty bitty box is
Yeah.
all of the answers to the final exam. You just have to squint really hard to see it. All right, I broke square root 48 over 49 to root 48 over 49. Agree? What's root 49?
Root 49 is
7. So this is going to be 7. Then I have to break down root 48. Root 48 breaks down to, I guess I could go 16 times 3. Where did I get 16 times 3?
16 is perfect square.
Yeah, 16 is a really big perfect square. You're absolutely right. Good. Okay, so if I didn't go that way, I could go 2 times 24, and then 24 is 2 times 12. Then I can break 12 down to 2 times 6, and I break 6 down to 2 times 3, which is 2, 2, 2, 2, 3. 2 times 2 is 4 times 2 is 8 times 2 is 16. That's where that came from. So I could break it down. Okay, what does this break down to then?
4.
For what?
4 square root 3.
4 square root 3 on 3 on top, all over 7. Check to see if the 4 and 7 reduce. They're both outside. They don't. So that's my answer. 4 root 3 all over 7. Root 288. I don't know. How does 288 break down? 2 goes into 288 144 times. Do I need to go any further? What's 144?
72.
So I have this. What's the square root of 144?
12.
12. So I get 12 square root 2 for an answer. Let's see. Root 90 over 33. Realize the radical doesn't go in the denominator, correct? So that's going to be the same thing as 9 times 10. 10 will break down to 2 and 5. Square root of 9 is 3. So I get 3 root 10 over 33. If that was a multiple choice answer, that would be one of them. But that's incorrect. Why?
You can say move one.
Do what? Reduce. What reduces? The 3 and the 33. Remember, you cannot reduce inside of a radical to outside of a radical as a fraction, but outside to outside goes well. And then we have root 40. Root 40 breaks down to 2 times 20. I don't know. Let's see. Hang on, we can do this. We know that that's 2 times 20. We know that 20 is 2 times 10. We know that that's the same thing as 2 times 2 times 2 times 5. This gives me a perfect square, yes? Square root of 4 is? 2. What's still underneath the radical? 10. 2 and 5, so it gives me 10. These are coming back to me. I think I should do okay on the final on this part. Can I do those last 3 on this page? I gotta take it too. I gotta make the key. So if I make mistakes on the key, guess what?
You will fail.
I won't fail, but you might have the right answer. I might have goofed. That's always possible. Oh, yeah. All right, 2 root 18. Root 8 and 4 root 50. So the number on the outside gets multiplied whatever the square root is. 18 breaks down to 9 and 2. Do you agree? Square root of 9 is? 3. 3 times 2 is? So I get 6 square root 2 on this problem. You see where it came from?
Yep.
Where does 8 break down to? 4 and 2. What's the answer then? 2 root 2. Why is it 4 root 2? Or 2 root 2? Because the square root of 4 is 2. What does 50 break down to? 25 and 2. What's the square root of 25? 5. What does that 5 do with that 4? Multiply. So what's the answer? 20 root 2. Done. Starting to come back? Do we need to shake off for a minute? Shake it off. All right, 37, 38. What do we do? Yeah, we combine like terms. Can I drop both sets of parentheses on number 37 without doing anything special?
No.
What's the difference between 37 and 38 as far as the sign in between the parentheses? One is subtraction, do you agree? So this top one, I just dropped the parentheses. All the signs stay the same. Agree? Okay, let's combine some like terms. Is there a like term to combine with that? Nope. Okay. And then I have squared terms. Is there a like term to combine with those?
Yes.
Now I get 4y squared. Cool. Is there anything to combine with this? No. And what about those? There's my answer. So if I'm adding the group stuff together, I don't have to change any signs. So 38, I get this. What changed? So this went here, here, and here. So note the signs have changed. This one changed, this one changed, and this one changed. Agree? So highest exponent is to the fourth power. So combine like terms. Here and here, what do I get? Negative 3x to the fourth. This and this, what do I get? 10x to the third. What do I get here? 11. Done. So common error on that one is you don't distribute that negative throughout, or it frightens you that its signs are changing. It's like, oh, it's okay. (39 through 44). Any of those you need to see. 39, you distribute 4x to the third over. Number 40, you're foiling. Number 41, you're foiling. Number 42, you're foiling. Number 43, you have 7x minus 4 quantity squared, which is 7x minus 4 times 7x minus 4 means you're foiling. And number 44, you're foiling on steroids, distributing big. Any of those that you need to see. 39 to 44. Bless you. 40? Yay? Anything up to 44? The other one that sometimes might be sore on you guys might be 44, where you have this. What do you think? I think we're pretty good with factoring, so the big ones on that might be the ones that have greatest common factors. Difference of two squares are a go-to. Any of those factoring ones that are sticking out that you'd like to see? Four? (96x to the third minus 48x squared plus 6x). That one? Okay, first thing I would say, look for greatest common factor. Greatest common factors can be a numeric value as well as a letter. Okay, so what letter do they all three can you factor out? X. X comes out right away. What number goes into 96, 48, and 6? 2 works, but does 6 go into all of them? 6 does go into all of them. So if I factor a 6x out, that gives me, well, I know that's going to be x squared. 6 goes into 96. How many times? 16. And then minus, right? 6 goes into 48 8 times, so I get 8x. 6x goes into 6x how many times? 1 time. Okay? So let's be careful with our problem. Be careful with our problem. 6x is definitely part of the answer. I know it should probably be like this. So our magic number here is 16. Both sides should be positive, positive, or negative, negative. How do I know that? Because that's positive. So which is it, positive, positive, or negative, negative to result here? Negative, negative. The factors of 16 are 1 and 16, 2 and 8, 4 and 4. Do any of those work? That would both be negative. That would add up to be positive 1. Do any of those work? Both be negatives that add up to be positive 1. Or negative 8, excuse me.
Oh, yeah.
Okay. So both negative. So I have 16x squared minus 4x minus 4x plus 1. What do I have in common here? 4x. If I factor 4x out, I'm left with 4x minus 1. That's negative, so I know I'm factoring what out? Negative 1. That leaves me 4x minus 1. So my answer is 6x, 4x minus 1, and 4x minus 1. Done. So, guys and girls, this is what I would do if I were you. One, this is recorded. We are up through basically number 58 on this. I have time to do one more up through 58. Come Thursday, we will try and finish out any of the last questions. But if you come unprepared, that makes it really hard to go through. Tomorrow, if everyone gets done with the math test that's on the computer, which is 30 questions, some are going to be like, dude, I got this. Some will be like, I've never seen this before. I know. So, Preston, what do you got? Yeah. Anything else you want me to go over? 3 minutes left up to 58. Billion points. Basically, if you're here doing the review, I will just put class points in.